So it simply asks us to determine the range of a function, of a trig function, y is equal to 2 cos x minus 1. Now, what you need to remember, for you to go and calculate the maximum or minimum for any particular trig function, this is what we need to do. All right, so this is what we're going to say. For you to go and find the maximum, right, for you to go and find the maximum is regarded as the amplitude plus, right, amplitude plus your Q value. Now, when I talk about your amplitude, I talk about those of you who do AD maths and AP maths, you know the concept of absolute. So the concept of absolute is basically the magnitude value. So when I talk about the magnitude of x, I'm talking about if x is equal to minus 3, and I say absolute value of x, the absolute value of x is actually just going to be 3, because this two lines here indicate absolute value, which indicates that it simply needs to be the number value or the magnitude. So when I go and talk about here, the absolute value of a, I'm just saying the number value. I'm not looking at the sign. I'm just looking at the number value for it. Now, we probably know this already, that the a value, amplitude, is the 2. The Q value is your vertical shift, and your vertical shift is there. It's your minus 1 at the end. So your maximum value, that's how you go and get it. Your minimum value is the negative version of your amplitude. Whatever your amplitude value is, it's the negative version of it. All right. So if this was, even if this was, let's say this was minus 3, then inside here, it's going to be 3. And then the amplitude's going to be, sorry, the value is going to be minus 3. I'll show you an example of that. But for now, let's just keep it as the positive plus Q. So the same rules still apply. The same rules still apply. So your A value is 2, done, positive version, plus your negative 1. So your maximum value is simply going to be 1. So your max value is simply 1. Your minimum value is going to be how much? So what is your absolute value or your magnitude of your amplitude? Your magnitude of your amplitude is 2. The magnitude of the amplitude there is 2. So you're just going to put minus 2 plus the vertical shift, which is minus 1. So it's minus 2 minus 1, which is minus 3. And whenever you talk about range, your range is always going from minimum value to your maximum value. Your range is always going to be your minimum value. So range here is basically going to be y as an element of real, and it's always going to be from minimum all the way to your maximum. So your minimum is minus 3, your maximum is 1. And why is it square brackets specifically? Because it's including those values, right? It's these square brackets here because it gets to minus 3 and it gets to 1. And that's how it will always be for your sine and cos functions, for your ranges, yeah? So that's what we're going to do there. Now I'm going to explain to you guys, in our particular case, what is our answer. I mean, it's kind of straightforward here. Our answer here, minus 3 and 1, is obviously going to be here. Done there. Now I'm going to explain to you guys what happens if this happens to be a negative, right? If that happens to be a negative, how do we sort that out? So I'm going to do it on the side. And then after that, if you guys have any questions, please let me know and I'll go through it, right? So on this side, we're going to do the same sort of thing, find the range for a slightly different function. I'm going to make this minus 3. Let's make it minus 3 sine. Minus 3 sine x. And it doesn't matter if you made this x minus 30, this middle piece has no bearing on the result. And we'll say plus 2. Okay. So if you want to find the maximum value is your absolute value of your amplitude. Or like I said, if you want to think of it as your magnitude, you can. Rules still apply. A value. Q value. So now, absolute value, what's just the number value of this? The number value of that is just going to be 3. Plus the 2. So our maximum in this case is 5. Not our maximum in that case is just 5. What would our minimum be? So our minimum is the negative version of our amplitude, of our absolute amplitude, I should say. So that's going to be there, and there's your Q value, you know. So here, this is going to be negative. What's the actual absolute value of that? We don't look at the sign. The absolute value of that there is just going to be the value of 3 plus the 2. And the minimum is minus 3 plus 2, which you know is going to give us minus 1. So in our particular case here, our minimum is minus 1 and our maximum is 5. And yeah, so this is going to be y is an element of real as the range, where it is from the minimum to the maximum from minus 1 until 5. And that's it there. That's how you'd find the range there. Now, for those who've joined in a little later, I just want to let you guys know, I am recording the lesson. So if you do want to watch it later on, you are welcome to watch it later on. I'm going to probably upload it onto YouTube. And yeah, you guys can watch it there. But I just want to find out, is there anyone who has any questions on what we've just gone through here? Right? You obviously are allowed to turn on your mic and ask, or you can send a message in the chat box. It's up to you. Is there any questions on what I've just explained here? This is, like I said, fairly easy. So Samia, why do we not add the negative? I'm assuming you asking for this negative over here. Like, why are we not putting this negative in there and in the value there, right? That's what we're talking about. Okay. So the reason why we do that is because, or the reason why we don't include the negative is because you deal with the absolute value. So the way a sine graph works, if you want to know the y behind it, it's always great to know the y behind it. So let's say you're dealing with a negative sine function. So let's say we have this here. So if you deal with a negative normal sine function, right? Negative sine x, I'll just show you something. What's going to happen? You'll start off at the bottom, right? So I shouldn't say you start off, but you start off going down, coming up, and then going back down, where you'd end up with a -1 and a +1. So now you see the following. Now you'll see the following. So now you'll see this as a minimum of 1 and a maximum of 1 because of that's the amplitude, right? Because that's the amplitude over there, right? That's the amplitude over there. Now, the next part of this here, which is why don't we include it in our max value and minimum value? Let me show you my next graph. So in my next graph, oops. In my next graph, I'll show you what happens if we call this minus sine x plus 1. What this means is that this graph here, right? This graph here, the sine x or minus sine x graph is going to be shifted 1 unit up. So what it looks like is the following. You'll see shifted up, it's going to look like this here. Right? It's going to look like that there. Where now we have minimum at 0. And if we're shifting it 1 up, the maximum is going to be at 2. So for us to go and figure out what the maximum would be, if we use our rule is simply saying that our maximum is supposed to just be the magnitude value. It's supposed to just be the magnitude value of that amplitude, just the magnitude value of that amplitude. So that's supposed to just be amplitude of -1 is actually just 1. Minimum is the amplitude value. Oops. It's the negative amplitude value of it. So if it's minus of your absolute value, then that's just going to be -1. Because remember, this, the value that I'm looking at is not the negative. I'm just looking at it as a positive. I'm just looking at it as the 1. I'm just looking at it as the 1. So if you do the same sort of thing on this side and use the same logic there, our maximum value is the amplitude value, just the number value there, just the number value, the absolute value there. Because if we don't use it, I'll show you what's going to happen. If we don't use it, let's say we go and put the negative here. If we're going to put the -1 here, right? If we're going to put the -1 here plus the 1, it's saying that my maximum value, it's saying that my maximum value is actually 0. And here it's saying that my minimum value is -1 plus 1, it's going to end up giving you the same sort of value, right? It's going to end up giving you the same like numerical value because it's not choosing a new starting point, right? It's not showing a new starting point. That's why when you're doing this, you have to make sure when you're doing the maximum absolute value, you know that this is technically a -1. This is technically a -1 here for -1 sine x. So it's amplitude value of A plus the vertical shift. So that's just 1 plus the 1, and that's 2. As we can see there, maximum is in fact 2. Minimum is the negative version of the amplitude, or the negative version of the absolute value of the amplitude, which is just -1 plus the 1, and that's 0. Perfect. We see the minimum is in fact 0. Done. I hope that clears that up. All right, brilliant. Okay, now going on to the next question here. So the next question is, which number is the greatest? Now this, unfortunately, is one of those like silly questions. Now to do this, obviously everything in NBT is without the use of a calculator. Please remember that every single thing in NBT is without the use of a calculator. So which number is the greatest here? Normally when we do this, we suggest convert everything to a denominator or to a common denominator, right? Convert everything to a common denominator first. You are also welcome to go and convert it to a decimal if it's easy to convert all to a decimal, right? But I'm going to do it by common denominator first. So I see the first one that I'm dealing with is 1/10, right? So the first one that I'm dealing with is 1/10. The next one that I'm dealing with is, okay, let me just make some space, is 0.2. Now 0.2, how can I convert that into a fraction? Simple. I'm going to shift the comma over. So it's basically 2/10, right? 2 divided by 10 is 0.2. Makes perfect sense. Then this 1 times 10 to the -2 is basically the same as if I take this to the bottom as a denominator. This will be 1/10 squared, 1/10 squared, which is basically 1/100. That's already a small number. Okay. Now the next one is 2/15. Okay, 2/15. Now this is where it gets cool. Now, obviously, immediately we can see that this one is nonsense. That one is nonsense already. We can see that's very difficult to get to. It's already going to be the smallest. Like there's no way 1/100 is going to be the biggest number. So it's not going to be correct. We can take that away. Right? We know that this one here is not going to be the biggest number. So what we'll do is we'll try and convert everything to a denominator of 10. So this one's perfect. Second one's also perfect, denominator of 10. So how do I convert this to a denominator of 10? Watch how cool this is. So maybe I'm overselling this with how cool it is, but let me explain. So the first thing you want to do is you want to get this to something that you can then times to get to 10, right? So the easiest way to do this is like, okay, if I divide this by 3, I know I can get to 5. So I'm going to divide this by 3. I know I can get to 5. So this is basically 2/3 all over 5, right? 2/3 all over 5. Now, if I times everything by 2, if I now times everything by 2, I'm going to get this as 4/3. 4/3 all over 5, right? 4/3 all over 5. Now, 4/3 is the same as what type of value, right? Let's figure out what 4/3 is. 4/3, just the numerator, guys, just the numerator is basically 1/3, right? That numerator is basically 1/3 all over 5. That's easy to understand, right? 4/3 is one whole number, one full number, and a third left. So let's go and compare this. 1, 2, and 1 and 1/3 all over. I'm saying over 5. I'm so sorry. That was so silly of me. It should have been over 10. 5 times 2 is 10. It should have been over 10. So it's 1 It's 1 and 1/3 over 10, right? 1 and 1/3 over 10. So if we compare it, let's go and confirm. 1 over 10, 2 over 10, 1 and 1/3 over 10, which is the greatest number? 2 over 10 is the greatest number for us then. So 2 over 10, which is 0.2, is our greatest number. Okay. Any questions on what I've just explained here? If you'd like me to explain it again, I don't mind explaining it again, but just let me know if there's anything at all, yeah? Okay, I'm sure you guys are close to done taking this down. So these are called composite functions, and that's also a fairly decently sized section in NBTs because it's not typically explained in school too often. In the normal government syllabus, in the IB syllabus, there's a touch of it in it, but in the normal government syllabus, it doesn't really get into composite functions. So I need to go and explain what exactly is going on here. So this is called a composite function because it's made up of f of x, it's made up of f of x and g of x. So what we are saying here, before I even do this question, I need to explain certain concepts that I feel we need to know first before we even get to composite functions. So what I'm going to explain here is very, very simple stuff. I know you probably know this. So if I say that f of x, if I go and say that f of x is equal to 3x minus 7, and I say that it's going to be f of 4, what this simply means, f of 4 simply means wherever I see x, I need to put 4. Wherever I see x, I need to put 4. Wherever I see x, I need to put 4 in brackets. So this is 3 times 12 minus, okay, 3 times 4 is 12 minus the 7, and then we go from there. So obviously from here, 12 minus 7, guys. Also, like I said, please remember no calculators involved for NBTs. I just want to remind you guys, no calculators involved. So 12 minus the 7 is just going to be obviously 5. And if you need to count it down with your fingers, however you need to do it, just do it that way. Just for the simple stuff, I know. Sometimes in the calculator, you still make sure like 1 times 1 sort of thing. But yeah, there we go. That's 5. So this is something that I expect you guys to definitely know. Right? I'm fully confident everyone understands that if it's f of 4, it means wherever you see x, you're going to substitute 4. Right? That's what we're getting at here. Now, what's going on this side is a very similar concept. So what we are going to do first, g of 2 is what we're going to start off first with. Right? G of 2. So we're going to write down g of x. G of x is equal to x squared. Now, g of 2 simply means wherever I see x, I need to put 2. Wherever I see x, I need to put 2. And there we go. I see x was there, so I put 2 there, and it's 2 squared. That's going to give me a value of 4. Right? That's going to give me a value of 4. So g of 2 is actually equal to 4. So now I'm saying the following, that g of 2 is equal to 4. So this entire piece there is actually now going to be regarded as f of 4. That entire piece there is now going to be regarded as f of 4. So now all we do is say f of x is equal to 2x plus 3. F of 4 is equal to what? Same rule still applies. Wherever I see x, I need to put 4 in brackets. So there we go. F of 4 is basically going to be 8 plus the 3, and that's the 11, and done. So our answer there is A. Now, anybody with any questions on this here, please let me know. Guys, please don't be shy. Anything at all, just let me know and I'll explain it again if I need to, yeah? All right. We seem to be okay. If there's a question, I'll come back and I'll explain it. All right. So this one, I think I'm fairly confident that you guys would be able to attempt this without me actually doing it first, right? So because this is fully going to be your normal grade 12 concepts from your series and sequences at the start of the year. So I'd like to give you guys an opportunity to attempt this, and let's see what you guys come up with here. All right, so please go and attempt this question here, and let me know what answer you guys end up getting here. Take it down, attempt it. Let me give you guys a few minutes. Let's say 3 or 4 minutes to attempt. If you have an answer, please send it through, and I'll let you know if it's right or wrong. Yeah. Okay, because I am about a minute away from marking it. So if you have sent your messages, I've actually only got one so far, but okay, wait. Did someone raise their hands? Okay, no, they've taken that away. I'll give you guys a little more time, probably another minute or two. But please make sure you guys, and again, I apologize. I know my handwriting is putrid. So if there's anything that doesn't look like a word or number, please let me know and I'll write it a bit better. But yeah, I apologize because I know my handwriting is not the best, but it's about understanding. So yeah, please please continue with your attempt. And yeah, I'll mark it in the next minute. Okay. Let's get started here. So I haven't gotten an answer yet, which is a little concerning. So let's go and see how we're supposed to think about this, obviously without the use of a calculator, and the process we're going to use. So start off here. Geometric series has a first term of 6. So now we know first term of 6 means that our A value is equal to 6. Sum to infinity of 18, done. Sum to infinity of 18. So start off there. We're going to say that the sum to infinity that we know is equal to A over 1 minus R. Sum to infinity is 18. The A value is 6, and then it's 1 minus R. Now, what I'm going to show you here is how you're supposed to rearrange your formulae. It's the easiest thing to do if you know how to do it in terms of cross multiplication and division becoming division becoming multiplication, multiplication becoming division. So let me not waste any more time. 1 minus R, I'm going to make division into multiplication and take it onto that side. So this is going to be 18 into 1 minus R is equal to 6. Now, I'm going to make life even easier because normally what you do is you'll distribute this. I don't want to do that. Multiplication here of this 18 is going to be division on that side. So this is simply going to be 1 minus R is equal to 6 over 18. Right? 1 minus R is equal to 6 over 18. Now I'm going to take the R onto that side to make it a positive. I'm going to take this onto that side there. But well, we should know this. 6 over 18. How many times does 6 go into 18? 6 goes into itself once. It goes into 18 3 times. So that's a third. So we have this as 1 minus R is equal to a third. We take it over. It's 1 minus a third is equal to R. And then minus. So 1 minus a third is going to be 2/3. But let me go and show something to you guys, right? Let me go and show something to you guys. That if you don't want to show it like this, you just make sure 1 is the same denominator as that there. So it's going to be 3 over 3 minus the third is equal to R. And therefore, this is going to be 2 over 3 then. Now, you put it as common denominator. Let's show that step. 3 minus 1. So therefore, R is 2 over 3. So now we've got our R value. We've got our A value. We've got our R value. We should be in the clear here. Now, they're not asking us to sum a massive amount of terms here, right? They're not asking you to sum 30 terms or 20 terms or 8 terms or 9 terms. It's just 3 terms, right? It's just 3 terms. So all you're going to be doing is you're going to take your first term. So term 1, which is going to be A, right? Term 1 is A. Term 2 is AR. I know that's starting to look like a 9. Term 3 is AR squared. That's also looking like a 9. It's AR squared. Now, your A value is 6. A times R, which is 6 times your ratio. What's your ratio? Your ratio is 2 over 3. And then your term 3 is going to be 6 times 2 over 3 all squared. So we're going to have this as 6. This is going to be what? This is going to be, okay, so what I'll do here is I'll basically do the following. I'll basically just, because normally, I don't know why this happens, but sometimes we forget how to multiply fractions because we get into the habit of cross multiplication. So I just want to make sure we remember that 6 times 2 over 3, right? It's not cross multiplication. It's just going to be numerator times numerator, denominator times denominator, okay? Numerator times numerator, denominator times denominator. So it's simply going to be 6 times 2, 1 times 3. So 6 times 2 is 12 divided by 3. And then the same concept for the next piece. The next piece is going to be 4 over 9, right? The next piece is going to be 4 over 9. So here, well, this here is going to be 6. This piece here, 12 divided by 3 is obviously 4. 12 divided by 3 is 4. It's a full number. And then here, if we go and do this, it's going to be 6 times 4, which is 24, over 9. But that needs to be simplified more, right? Because I know it doesn't look like 24 and 9 are going to be, you can simplify it, but you got to check. You got to make sure you go and check. So what can you divide 24 by, and what can you divide 9 by? You can divide 9 by 3 and 24 by 3. So that's 6, 4, and then 24 divided by 3 is 8, 9 divided by 3 is 3, and then you add this up. And then you simply add this up. Now, I want to show you another way to go and do this here, right? Because I don't particularly like this version, right? I don't particularly like this version over here. So the alternative way of doing this here, for 6 times this 2 over 3 times 2 over 3 is the following. So I will do it like this here. I'll say that this 2 over 3 squared is basically 2 over 3 times 2 over 3, right? I know that. It's basically 2 over 3 times 2 over 3. So I already know that 6 times 2 over 3 is 4. I already know that that portion is 4. So it's basically 4 times 2 over 3. And now, numerator times numerator, 4 times 2 is 8. And that's 8 over 3. And I feel like this is a much simpler way of doing it than that there. Right? And you've got to know different ways of doing things in terms of multiplication for your NBT. You want to find the easiest way that works for you. Right? You want to find the easiest way that works for you. Right. So now that we have that there, we're just going to add it up, right? We're just going to add it up here. So 6 plus 4, we know that this is 10 already, right? We know that this is 10. So 6 plus 4 plus 8 over 3. You can say that it's 10 plus 8 over 3. So all we're going to do now is we're going to get it to a common denominator. So I need to times this 10 by 3 because currently this is over 1. Right? This 10 is over 1. Let me write that better. This is 10 plus the 8 over 3, and this 10 is over 1. So common denominator of 3, which means I would have times by 3 times this by 3. This is going to be 30 plus 8, and obviously that's 38 over 3. And our answer is our first one. Our answer is 38 over 3. So I hope this makes sense. If there's anyone who has any questions on this, or anyone would like me to explain it further, please let me know. I'll be happy to go through it. But I think more than anything, NBT is about understanding how the simple maths works, right? The simple maths. All right. Now, question 5. This one, I think you guys would be able to do. So I also want to give you guys an opportunity to attempt this one here, and then I'll do question 6 thereafter. Let me just make some space here. So question 5, it says that if tan of angle A is equal to 3 and A is between 0 and 90. So basically saying it's in the first quadrant. Let me just also indicate that. If it's between 0 and 90, it's basically just saying that it's in the first quadrant. Right? Just saying that it's in the first quadrant. And it's asking us to find the value of sine of 2a. So please go and attempt that there. Yeah? You guys should be okay. Okay, so what I just want to make sure is when we're doing this, we kind of draw the triangle because everyone now knows how to draw the triangle to relate this here. So I'm putting this really small here as 3 over 1. And remember that this is basically opposite all over adjacent. So when we draw this triangle here, angle A, opposite is going to be 3, adjacent is going to be 1, and then the hypotenuse is going to be how much? So hypotenuse squared is basically going to be equal to 3 squared plus the 1 squared. So hypotenuse squared is going to be 9 plus the 1. Hypotenuse squared is going to be 10. So obviously hypotenuse is just the square root of 10. So this is just the square root of 10. So hypotenuse is just the square root of 10. Easy stuff. Now, from here, I know you guys, also you'll get a formula sheet, just so you know, you'll get your normal matric end of year formula sheet in your NBT. So these sine double angles and cos double angles and sine and cos compound angles are all going to be there. So sine of 2a, I'm fairly confident, all of you know, that sine of 2a is equal to 2 sine a cos a. So now that it's broken up, now it's simple. So 2 times sine a is opposite. We know sine a is going to be opposite all over hypotenuse. Opposite all over hypotenuse, so 3 all over root 10. Cos a is adjacent all over hypotenuse. So adjacent all over the hypotenuse. And remember the rule, guys. Remember the rule. Numerator times numerator, denominator times denominator when you multiplying fractions. So it's 2 into 3 times 1. 3 times 1 is just 3. And then root 10 times root 10 is just going to be the value of 10. Just going to be 10, right? It's just going to be 10. Right? It's just going to be 10. Now here, we're going to have this as 2 times the 3, which is going to give us 6 over the 10. And our answer is then going to simplify into 3 over the 5. Now, let me just, okay, so I made a mistake here. This was supposed to be our answer here. Sorry, it was supposed to be 3 over the 5 here. I made that mistake there. I apologize. Right, so that there would have been 3 over the 5 there. Divide by 2, divide by 2. Now that's going to be 3 over the 5. Sorry about that. When I sorted out this question, I think I took down that option as 3 over 10, but it should have been over 5. I apologize. So as usual, if you have any questions on this, please let me know. I'm hoping that it does make sense. Right, so this, again, I'm quite confident that you guys have done this sort of concept before with regards to your trigs, like last year and the year before. So I'm hoping that kind of gels better, especially for the NBTs. Now, this question 6 is a common question or question type for NBTs, right? It's a very common question type for NBTs. So I want to go through this here, but first I want to make sure that you take this down. I'll give you like a minute or probably a few seconds, maybe 30 seconds to take it down, and then we can get marking with this because I need to explain what we're looking at here. Right, you should be done with taking this down. So I'm fairly confident as well. Yeah, you may have seen this if you've done a few NBT questions from like other papers or perhaps NBT questions online. The concept is very similar to other NBT sort of questions. So here, we need to figure out what is x squared plus 1 over x squared. Now, what to actually start off is we need to start off with our top piece of x plus 1 over x. And we need to recognize that the only way we can get to this x squared concept is if we square this and that. We square both sides of the equation. So how do we square a binomial? I know you guys know this. You might have it, you might know it's slightly different in terms of how I'm going to do it, but the method is the same. So the way I do it in my lessons is square the first. So x, if you're going to square x, it's just going to be x squared. You are going to multiply the 2, and then times by 2. So I'll do that on the side here. So it's going to be x times 1 over x times by 2. Multiply the 2 and double, or multiply the 2 and times by 2. Right? So, yep. X times x. Well, this x is going to cancel out with that x, and it's just going to be 2 into 1. So this is just going to be 2. So run through it one more time. We're the first. So x squared is just going to be x squared. Multiply the 2 and then double. We multiply these two. They're going to cancel out and just give you 1. And if you double it, double 1, you're just going to get 2. So now we have this as plus 2 here. Squaring the last now. Squaring the last. So if you square the last one, that's going to be 1 over x squared, because 1 squared is just 1. And x squared is just x squared there. And this is just equal to 25. All that happens from here is you're going to take this 2 over onto that side there. X squared plus 1 over x squared is 25 minus the 2. X squared plus 1 over the x squared is equal to 23. And that's done.